Whoa, I just changed someone's password. They have no idea, and all it took was editing a URL. Hey everyone, welcome back to the channel. And what you just saw, it was me changing someone's account email and practically taking over their account. Not by guessing the password, not by resetting it with your email, just changing it with a weird URL. And I'll show you what the URL looks like in some minutes. So it's a bug, and it's not IDOR, it's not CSRF, it's something called Client-Side Path Traversal, in short CSPD, and most scanners won't even flag it. So in this video, I'm going to break down exactly how this works, walk you through the exploit step by step in my home lab, because this bug has paid out real bounties on real programs, including 4-digit bounties. So yeah, let's get into it. Okay, so I'm logged into this application that basically sells handmade keychains. As you can see, some products over here. And if I go to my profile icon, I can see my account settings. And by the way, you won't find this website in real life. This is literally in my local host. I created this lab to demonstrate this vulnerability, okay? Well, so in account settings, we have few options. First is to change recovery email. We can change the email. And another option is we can change the password if you want to. The one that we are interested in is change recovery email, because if we can change the email of the victim, we can log into their account. And we want to do it by exploiting CSPD bug. Let's go to homepage first. Okay, back in the home page, over here we have some charms, and let me open my inspect so we can see what's going on in the networks tab. Okay, let me just click on view similar. So when I click on view similar, it basically shows me products that are similar to the product I clicked on. That is mini teddy, brown beer, neat beer. So the API request that made it happen is over here, and it looks like this: /API/product/teddy/similar. And in the response, we get items listed in JSON format like this. Okay, so let's click on another product as well. Let's click on Sakura petal. They're so pretty. Okay, so we have API path. Okay, similar, but what's changing over here is the product name. So whenever you click on the product, the name changes over here. Let me zoom it out so you can see. So currently the product name is Sakura, so it got changed here. If we click on dragon, we will see dragon over here. So we want to understand how this is working. Let me minimize it. Over here we can see that we have product parameter in the URL, and the value is dragon. So it's most likely fetching the value from this product parameter and appending it over here. To confirm that, let's go to the JavaScript file and see what's going on. Okay, let me search up /similar, because that's the path we looked in the networks tab. Okay, so we have this line of code, let URL, basically defining a variable URL, and then in the value we have /API/products, and then the name of the product, and then /similar. So as you can see, the product is actually a variable name, and it's getting replaced with the value that is provided in the parameter over here. So whatever value you provide over here in the parameter, it gets appended in this path. And this is kind of dangerous. Why? Because the value could be anything. It could be some kind of payload as well. Let me try something. Let's say, oops, cat. So of course there is no product cat, but if we go to the networks tab, we'll see that cat value gets reflected over here. It means that this value got appended in the API path. And why this is happening? Simply because same logic I showed you in the JavaScript code. So now we know that what's the vulnerable line of code here that makes it possible. It's exactly this line. Now we need to exploit the functionality of changing email. How we can do that? Before I move into that, I want to give a little bit introduction about CSPD. So CSPD is similar to CSRF. What happens in CSRF? You basically perform some action on behalf of victim, right? You give a link to victim, and then The victim clicks on the link and then a random form gets submitted. It could be password reset form, and the password gets changed. Similar to that, we are also performing some action on victim's behalf, but in this case, we are not submitting any form. We are just telling the application to make an API request to a particular URL. So the application will make that request without realizing what it's doing, and then the email will be changed. Let me open my notepad. So I'm pretty sure a lot of you are aware about path traversal vulnerability, where you use payload like // etc password. And when you do this, you basically get a dump of the users and password list from the Linux server, right? Similar to that, we use the same path traversal payload in CSPD as well, but it's not making a request to the server. It's basically making a request to the application itself. Everything happens on the client side, okay? That's it. That's why it's called Client-Side Path Traversal, because it happens on client side. Now let's move on to the exploitation phase. But before we do that, we need to find out what the API endpoint looks like for changing the email, because we will be using that to construct the payload. So let's open the networks tab again. And then I'm going to type, let's say, test1 at example.com, update email. So over here we get a get request. Okay, so we have get request here, and we can see that we have two parameters: new email that contains the new email that we just provided and the old email. What else do we have? We have cookies, okay, and there is no any other type of authentication that is happening here. Okay, so since there is no other kind of authentication, all we have to do is send a URL, and when the victims click on the URL, the cookies will be assigned automatically in their request, because that's normal browser behavior. So nothing else we need to do, and that's why this is vulnerable. Let me open my notepad again. Okay, so before we move on to the actual CSPD payload that will make this happen, we first need to understand how browser normalization works. I've also talked about this in very detail in my webcast reception series, and that vulnerability is also very simple and very rewarding, so I think you should check that out as well. You can check that out from the I button. But for this video, let's first understand a simple scenario of browser normalization. Let's say there is path something like this: /API/account/details. Okay, so as I said, client-side path traversal payload usually contains // segments. So it usually looks like this: account details. It's part of the browser that whenever the browser sees some weird segments like this, it's supposed to remove such, because that's not a valid URL, right? That's just in the policy of the browser, RFC something, so that's just how it works. What happens is the browser is simply going to keep this, okay, /API/ and it's going to remove account. Why is it going to remove account? What does this mean even? This means that go one directory up, similar to the logic in Linux. When you do // you go one directory up. Let me show you. Okay, so let me go to labs. So currently this is my path, right? But if I type like this, cd ... what does this mean? Okay, let's just type the same segment we saw here, // right? If I do this, I'll go to my home directory, home Medusa. As you can see, labs is gone now. We just moved to this part. So this basically means go one directory up. If I do cd ... something like this, it will go two directories up. It means we will end up in exactly home directory. And as you can see, we're in home directory. So same logic applies in the browser here as well. When you provide // segment, basically you go one directory up. So it goes one directory up and it ends up in /API. And then we have /details that still there, so the browser just keeps it. Okay, so this is how the resultant looked like after the normalization. This is the behavior that CSPD exploits. In this case, we want to construct a URL that basically moves the user to update email endpoint and make the request to change that. So as we know that the name of the parameter is product equals /API/product, right? Something like this. And then the name of the product and then similar. This is how the normal behavior was. But we will apply some dot segments over here. Okay, so let's also type the path for the change email. It was like this, /API/account/change email, new email. And then let's say medusa@example.com. So this is the new email I'm changing for the victim user. Okay, so as we know that this is the change email path, let's copy this whole thing and let's paste it in my notepad over here. Okay, so we want to change the email to the attacker email. So let me type medusa at example. Oh, my fingers are tripping. And we don't need this part. We don't need to guess that because if you notice here, there is no field to provide the previous email. We only have to provide the new email, and the previous email just gets appended by the browser itself from the local storage. So we don't need to do that. All we have to do is create this part. So this part is actually going to go over here. That's exactly what we're doing, right? We are exploiting that product parameter because the value, whatever value that goes in the product parameter, gets appended in an API path, and the application makes call to that path. And that's why we want the application to make call to this path. But this is still not correct because we have to add some /sequence. So for that, we are simply going to add // over here like this, and we are going to change this question mark to ampersand because there is already one parameter, and usually when there are more parameters in the URL you have to add ampersand, not question mark, because that will be the wrong URL format. And that's why I say that fundamentals are so important. If any of you have not cleared your fundamentals of how URLs even work then this would be confusing. But this is actually pretty simple for anyone who has cleared the fundamentals. So the resultant URL after normalization will look like this. So it goes one directory up, and that makes it API, then account, change email. And we also know that from the application logic, we saw this in the JavaScript code that whatever path is there, similar is appended at the end of the path, right? So similar is getting appended here. And then we have our parameters. Now you might notice the final request has /similar, and this is because of the application logic. We saw in the JavaScript that whatever path goes in, /similar gets appended at the end of the path. But that's still not part of our payload. The JavaScript hard codes that /similar after the product parameter, so we can't avoid it. It always gets appended no matter what value we inject, but it doesn't break the attack because the server uses prefix-based routing, meaning it checks if the path starts with this /API/account/change email. If the API endpoint starts with this, then the server or the code logic is going to ignore anything that comes after it means this. And that's why this is still going to work. Okay, now you must be thinking, okay, which one of this are we going to deliver as an attack? We are going to deliver this payload. This is the same as this one, actually, nothing different. As you can see, account, change email, new email, everything same. So let's just construct the whole URL, http localhost. Obviously, in real life application, you'll be providing the actual URL of the application. And then we also have to provide shop.html because everything gets appended after that. Question mark product. Okay, so this is the whole CSPD payload, and it can change anyone's password if they click on it. So let's deliver this attack, copy this payload, paste it in the browser, hit enter. Okay, so we see that error loading products because obviously there is no product like that. But if we look what happened in the background, we can see that a request goes to this path. As I said, that slash similar will be appended whether we like it or not because it's in the application logic, but this still changes the user's email, recovery email updated. Okay, so yeah, this works. So let's go back to the profile icon so we can confirm that the email is indeed changed, and yes, it is. We can see the new recovery email. So that's how CSPD works. Two important takeaways from this book is understanding browser normalization, and another is understanding where the user input is falling into and whether that user input is being used in some way to make an API call. That's it. Let me know your thoughts in the comment section. I really had fun covering this vulnerability. So thank you so much for watching, and I'll see you in the next one.